Circumference, arc length, and sector area. Welcome to this explainer. We're going to dive right in and figure out exactly how to measure curved edges and, well, pizza slices, just by treating them as simple fractions of a whole circle. Whether you're dealing with an actual slice of pepperoni pizza or calculating the reach of a lawn sprinkler, geometry doesn't have to be this messy list of complicated formulas to memorize. Instead, we're going to use just one incredibly powerful logical concept to unlock the whole shebang.
Now check this out. Here is our master key for literally everything we'll do today. Any piece of a circle is just a simple fraction of the total 360 degrees. Take a look at the 90-degree angle highlighted right here. It represents exactly 1/4 of the whole circle, right? So intuitively, you can see that whatever happens inside that specific slice is going to be exactly 1/4 of what happens in the entire circle. This part-to-whole relationship, it's the foundational engine driving everything we're about to do.
The whole circle foundation, circumference, and area. Before we can find the parts, we've got to establish the foundational rules for the whole circle.
Because honestly, you have to know what your whole is before you can take a fraction of it. So let's look at the difference between our two main properties. On the left, we have circumference. Think of this as the perimeter. It's that one-dimensional linear distance around the outside edge, and you find it with the formula c equals 2 times pi times the radius. Now on the right side, we've got area. Area is the two-dimensional flat space filling up the inside of the circle, measured in square units, and found using a equals pi times the radius squared. If you can keep these two straight, 1D distance versus 2D space, you're going to completely avoid the most common geometry pitfalls.
Arc length as a fraction, the crust of the pizza. Let's move on to our first specific part of the circle.
You can literally just think of this as the crust on your pizza slice. The official math term here is arc length. If the total circumference is the whole outer track of our circle, the arc length is just a specific segment of that track. And how do we know how long that segment is? Well, it's dictated entirely by the central angle. An angle formed at the center of the circle by two radii, basically, sweeps out a perfectly proportioned portion of the edge.
All right, time for a quick pause check. If a central angle is 180 degrees, what fraction of the total circumference is the arc length? Go ahead and hit pause, think about it for a sec, and then we'll verify your answer together.
Got it? So the crucial point here is that 180 degrees divided by the total 360 degrees of a full circle simplifies down to exactly 1/2. That means your arc length is simply half of the total circumference. See? No brand new formula needed. You literally just take your central angle, put it over 360 to get your fraction, and multiply that by your standard circumference formula, 2 times pi times radius. Super simple.
Sector area as a fraction, a slice of the pie. Now that we've completely mastered the crust, let's calculate the 2D space of the entire slice. We're shifting from a 1D linear measurement to a 2D area measurement. This region is called a sector, and just like we saw with arc length, the sector area is simply a fraction of the circle's total area. Once again, you find it by taking your central angle and dividing by 360 degrees. The logic here is just beautifully consistent. If your angle takes up, say, a certain percentage of the 360-degree rotation, then the area bounded by that angle takes up that exact same percentage of the circle's total area.
Let's do our second pause check. Pause the explainer, calculate the fraction for a 45-degree angle, and let's see if you've really got this pattern down.
Let's check it. Since 45 goes into 360 exactly 8 times, your sector area is exactly 1/8 of the total area. If you are actually calculating the total value here, you just multiply that 1/8 by the standard area formula, pi times radius squared.
Solving a real-world example, the lawn sprinkler. Let's see how this all builds into a real-world geometry application straight from our source material.
This is where we're going to put that master key to the ultimate test. Here's the scenario. An automatic lawn sprinkler sprays a distance of 20 feet, so that's our radius, and it rotates through a 30-degree angle. We are going to calculate both the 1D arc length the water travels along the outside edge and the 2D sector area of the grass that actually gets watered.
To solve this like an absolute pro, we'll use the precise 3-step game plan. Step 1, find our fraction. Step 2, multiply that fraction by the appropriate whole circle formula. And Step 3, verify our units and make sure our final answer actually makes sense in reality.
All right, Step 1 gives us our fraction. 30 degrees divided by 360 degrees simplifies beautifully to 1/12. So right off the bat, we know our sprinkler covers exactly 1/12 of a full circular lawn.
Now for Step 2, the arc length. We just multiply our fraction, 1/12, by the total circumference. That's 1/12 times 2 times pi times our radius of 20. If you punch that into a calculator, using 3.14 for pi, you get roughly 10.47 linear feet. Now moving to step 3 to verify. Feet is the correct 1D linear unit for an outer edge. And honestly, it makes perfect sense that a small 30 degrees slice of a massive 125-foot circumference circle would just be a little over 10 feet long.
Next up, the sector area. We multiply our 1/12 fraction by the total area, which is pi times our radius of 20 squared. Well, 20 squared is 400. 400 times pi is roughly 1256. And 1/12 of 1256 gives us 104.72 square feet. Notice the units, square feet. That is perfect for a 2D area. And checking for reasonableness, taking a 12th of roughly 1,200 square feet gives us an answer right around 100. So yeah, 104.72 is totally spot on.
A quick, concise recap. The part to whole master key. Okay, let's wrap this up by summarizing exactly what you should take away from this explainer today.
By anchoring everything to that simple fraction of your angle over 360 degrees, you don't need to memorize complex new formulas for arcs and sectors. You literally just apply your basic, familiar whole circle rules to the fraction you're working with. Just remember to always attend to precision by checking your units, 1D linear units for arc length and 2D square units for area.
Your final transfer question, working in reverse. To conclude, I want to leave you with a bit of a provocative puzzle to test how deeply you actually understand this part-to-whole relationship. We've spent this entire time finding the parts when we were given the angle. But what happens when we flip the script? If you know the sector area and you can calculate the total area using the radius, how could you mathematically work backward to find the central angle? Think about how you'd reverse the 3 steps we just took. You can divide those areas to find the fraction, right? From there, see if you can untangle the algebra to isolate the central angle out of 360 degrees. Give it a try on your own. Because if you can unlock this, you can master literally any circle geometry problem thrown your way. Thanks so much for watching this explainer.